This is Algebra 1, Lesson 2.7, Division of Real Numbers. Two goals: we're dividing real numbers and we're using them to simplify algebraic expressions, beginning on page 108. First thing's the definition of what a reciprocal is. It says if A over B is a non-zero number, that just means if it doesn't have zero in it, then its reciprocal is B over A. The product of a number and its reciprocal, that means when you multiply a number and its reciprocal, you get 1. Okay, all reciprocal is a fancy word that means flip it. So if you're talking about the reciprocal of something, 1 over 2, when you flip it, becomes 2 over 1. The division rule is to divide a number A by a non-number 0b, multiplied by its reciprocal. So the division rule means in order to divide something, you change it to multiplication. With fractions, it's easy. Like, for example, 1 over 3 divided by 2 over 6. And I know that's not a simplified version, but that's okay. 1 over 3 divided by 2 over 6. With fractions, it's easy. You leave the first fraction as 1 over 3. You change it to multiplication, and you multiply by the reciprocal. 2 over 6, you multiply by 6 over 2. Okay? You can do the same thing with integer numbers, like -1 divided by 3. You multiply -1, the division becomes multiplication, and 3, as a reciprocal, 3 becomes, it's everything's considered over 1. When you flip it, it becomes 1 over 3. So then it's just -1 times 1 over 3. Here's example number 1. -3 over 4 divided by 5 over 12. Again, division becomes multiplication, and 5 over 12, you flip it. So -3 times 12 is going to be -36, and 4 times 5 is 20. The number 4 goes into both. 4 goes into 36 9 times. They just give you the simplified version here, -9, and it goes into 20 5 times, so -9 over 5. Then this step right here is simply just making it back to a mixed number, which is a couple of y'all asked questions. That might be where you were not sure what to put on that second or that last one right there. For B, 3 and 5/9 divided by 2 and 2/3. First thing, you have to make both of those mixed numbers into improper fractions. Again, multiply 3 and 5/9. You multiply the denominator times the whole number. 3 times 9 is 27, plus the numerator, 27 plus 5 is 32. So 32, and then it goes back over the original denominator. Notice we got 32 over 9. So 32 over 9, you do the same thing with 2 and 2/3. 3 times 2 is 6, plus 2 is 8 over the original denominator of 3. So 32 over 9 divided by 8 over 3. This is the step we're at now. This is the step we're at now. 32 divided by 9, or 32 over 9 divided by 8 over 3. Multiply, change division of multiplication, and flip 8 over 3, or make the reciprocal into 3 over 8. So 32 times 3 is going to be 96, and 9 times 8 is going to be 72. That simplifies to 4 over 3, and in that last line they just make it back into a mixed number, 1 and 1/3. Again, you're changing division into multiplication, and you're flipping the second fraction. Next one says 5 over 2 divided by -25. Remember, everything can be over 1. So that's what we have here, -25 over 1. Change division to multiplication. Make it say -1 over 25. Flip it. Use the reciprocal. 5 times -1 is -5. 2 times 5 is 50. The number 5 goes into both. It goes into 5 one time, and into 50 10 times, -1 over 10. And then the last one, 1 divided by -5 over 8 is equal to 1, and that's how it just says it here, divided by -5 over 8, which is 1 times, remember, in order to divide fractions, you multiply by the reciprocal. So division becomes multiplication, and -5 over 8 becomes -8 over 5. So 1 times -8 over 5, if you multiply straight across, it becomes -8 over 5, which simplifies back to the mixed number, -1 and 3/5. The sign of a quotient, the quotient of two numbers with the same sign is positive, okay? So just like multiplication, positive times positive is positive. Negative times negative is positive. Division acts the same way. It follows the same rules as multiplication. Opposite signs are going to be negative anytime they opposite. So right here, negative A divided by negative B is going to be positive. Negative 20 divided by negative 4, same sign, is going to be positive 5. The quotient of two numbers with opposite signs, it's just like multiplication again. Negative divided by positive is negative, and positive divided by negative is negative. It's just like multiplication. Opposite signs is negative. So negative A divided by B is going to be negative since they're opposite. Negative 20 divided by 4 is going to be negative since they're opposite. Here's a distributive property to simplify. 56x minus 14 divided by 7. So 56x minus 14 divided by 7 can be rewritten this way. And this is one of the few times in this class where we'll rewrite it with that little division symbol. Remember, I told you to use it, the over symbol, all the time. It makes it a whole lot easier. That's the same thing as times 1 over 7. Remember, dividing by a number is the same thing as multiplying by its reciprocal. So 56x minus 14 times 1 over 7. Then you just distribute 1 over 7 times 56 and 1 over 7 times negative 14. 1 over 7 times 56 is going to be 8x. I should have said 56x. And 1 over 7 times negative 14 is negative 2. Example number 3 is evaluating an expression. It says evaluate the expression when A is 1/3 and B is negative 2 over 5. Negative 15 over 18 divided by A can be written as negative 15 over 18 times A's value is 1 over 3 times 3 over 1. You use a reciprocal. 1 over 3 becomes 3 over 1. When you multiply straight across, negative 5 times 15 is going to be negative 15. And 18 times 1 is going to be 8. The number 3 goes into both of them. It goes into 15 5 times, and it goes into 18 6 times. So negative 5 over 6. Okay, for example B, example 3, letter B, it says 3 divided by 2 over 5 plus B. So it says plus, we're putting in B's value, negative 2 over 5. So when you put in 2/5 plus negative 2 over 5, notice when you substitute it in, you get 0 at the bottom. So you get 3 over 0, which makes it undefined. If you look off to the left, it says, remember that 0 can be divided by any non-zero number. So 0 can be at the top of a fraction. Anything could be at the bottom. The result will always be 0. However, division by 0 is undefined. It can never be divided by 0. If you have a calculator and you punch in something and you press divide by 0, it'll say error, or it'll say syntax, or it'll say something like that. Negative 8 divided by B is equal to negative 8 divided by B's value, again, is negative 2 over 5. Remember, division, all it means is multiplying by the reciprocal. Negative 2 over 5 becomes negative 5 over 2. Negative 8 over 1, when you multiply straight across, negative 8 times negative 5 is positive 40. 1 times 2 is 2. 40 divided by 2 is, in fact, 20. Example number 4 is finding the domain of a function. Okay, so we have the function y equals 3x over 2 plus x. It says input some sample values of x. So it just uses the values negative 3, negative 2, 1, 0, and 1. You'll get familiar with using those numbers when it comes, especially in Algebra 2, when you're graphing parabolas and you're graphing quadratic equations. 3 times negative 3, we're just subbing in this value, over 2 plus negative 3. So 3 times negative 3 is going to be negative 9. 2 plus negative 3 is 2 plus negative 1, which means, 2 plus, minus 3, which is negative 1. Negative 9 divided by positive 1. Negative divided by negative is a positive 9. When you plug in the values negative 2, 3 times negative 2 is negative 6. And 2 plus a negative 2 is the same thing as 2 minus 2. You get 0. That's why it's undefined. Again, this is the value that it can't be. It can't be negative 2. X's value, when you plug it in, 3 times negative 1 is negative 3. 2 times negative 1 is negative 2. I'm sorry, 2, it says not times, plus. I keep reading it wrong. 2 plus negative 1 is the same thing as 2 minus 1. So you have negative 3 over positive 1, which simplifies to negative 3. When you plug in 0, 3 times 0 is going to be 0. 0 divided by anything is going to be 0. And then when you plug in 1, 3 times 1 is 3. 2 plus 1 is 3. 3 divided by 3 is 1. So here's all your values when you plug in these sample values from negative 3 to positive 1. You get 9, undefined, negative 3, 0, and positive 1. And when you look on the bottom, it says from the list, you can see that x equals 2 is not in the domain of the function. So we found the domain by finding what was not in it. It says because you cannot divide by 0. All other real numbers are in the domain because there are no other values of x that will make the denominator 0. So the domain is all real numbers, so every number that we're going to work with besides negative 2. Then it says evaluate the expression. We have a checkpoint. A over negative 2b when a is negative 1/5 and b is 11 over 20. So a is negative 1/5 over b over negative 2 times b, which is 11 over 20. So this is what we're working with right now. Another way to write this, these will be one of the few times that you might want to write it like this. Negative 1 over 5 divided by, all that is this line here, divided by negative 2 times 11 over 20. Remember, you can make everything over 1. So when you multiply, you can multiply by this. Remember, you want to take this first fraction and leave it alone, negative 1 over 5. Division becomes multiplication. Negative 2 over 1 becomes negative 1 over 2 times 11 over 20. So we just multiply straight across at this point. Negative 1 times negative 1 is positive 1, and positive 1 times 11 is going to be positive 11. 5 times 2 is 10, and 10 times 20 is 200. So we have 11 divided by, or 11 over 200. I feel like I got to work that one again, but let's go to this next one real quick. It says find a domain, y equals 3 minus x. Use the same x values that we used in the example. Negative 3, negative 2, negative 1, 0, and 1, and plug them all in. So y equals 3 minus x over x minus 5. So 3 minus negative 3 is going to be 3 plus 3, which is 3 minus negative 3. 3 plus 3, which is going to be 6. And x minus 5 is negative 3 minus 5, which is negative 8. So you have 6 over negative 8. When you plug in negative 2, 3 minus, we're going to go a little quicker. 3 minus a negative 2 is going to be 5. Negative 2 minus 5 is negative 7. When you plug in negative 1, 3 minus a negative 1 is going to be positive 4. Negative 1 minus 5 is negative 6. Negative 4 over 6 is the same thing as negative 2/3. When you plug in 0, 3 minus 0 is going to be 3. 0 minus 5 is negative 5. And then when you plug in 1, 3 minus 1 is going to be 2. And 1 minus 5 is going to be negative 4. Again, 2 goes into that one, negative 1 over 2. What it's trying to get you to understand, though, like it says about the domain a minute ago, is you're trying to find the number that when you plug it in place of x, you get 0 on the bottom to create what's not the domain. The only thing that makes that 0 is the number 5. So it's going to be all real numbers except, again, all real numbers except the number 5. So all real numbers except the number 5.